So if this video is 2,400 seconds long, how many minutes is this video? Well, in order to determine that, we need to convert our seconds into minutes. So how do we do that? Well, the first step is we need to know the conversion factor from seconds into minutes. So you'll just look in a textbook and you'll see 60 seconds is the exact same thing as 1 minute. So that's the conversion factor. 60 seconds equals 1 minute. These both physically represent the exact same thing. So now that we know our conversion factor, all we have to do is multiply our 2,400 seconds by this conversion factor. And we need to set up our conversion factor in a very specific way that allows the seconds to cancel out. So now we're left with minutes. So now we're left with units of minutes. So our answer will be in unit minutes. So again, we have to set up our conversion factor in a way so the seconds is in the denominator. So therefore the seconds will cancel and now we have minutes. But something important to realize is that 1 minute, again, is physically the same thing as 60 seconds. These both physically represent the exact same thing in our universe. So therefore, we can see this conversion factor really equals 1 because we have 1 minute over 60 seconds. And these both represent the same thing. So this conversion factor is really the same thing as 1. And that's good. That's important because we don't want to change this 2,400 seconds. We don't want to take this 2,400 seconds and multiply by 2 and therefore doubling the amount of time. We don't want to do that. We want to keep it the same amount of time. All we want to do is take the units and convert it into minutes. So it's important for this conversion factor to equal 1. Because again, now we're not physically changing the amount of time. The utility of this conversion factor is taking the seconds and converting it into minutes. And that's why we set it up in this way, for the seconds to cancel out, and now we're left with minutes. So again, all this is doing is changing the units, canceling out the units and giving us minutes. So now we have our answer. So now we would get our answers 40 minutes. Again, seconds cancel, so we're left with minutes. And then we just do the math. 2,400 times 1 divided by 60 equals 40. So now we know 2,400 seconds is the exact same thing as 40 minutes. So whenever you're doing these unit conversion questions, there are 2 steps. The first thing is you want to set up the units to cancel and to give you the units you want. And the second thing is to set up the numbers. So let's do another example. So let's say a movie is 9,000 seconds long. How many hour long is that movie? Well, again, first we need to take seconds and convert it into minutes. Then we need to take those minutes and convert it into hours. So therefore, you would have to set up the units to allow that to happen. So again, we would set up the units, these conversion factors, in a very specific way that allows the seconds to cancel. And now we allow the minutes to cancel, so now we're left with units of hours. So our answer will be unit hours. So that's the first step. The first step is to set up these conversion factors in a very specific way that allows the units to cancel, and we're left with the units that we want. So that's the first step. And remember, we don't want to change this. We again, all we want to do is take the units and convert it into hours, but we don't want to physically change the amount of time. We want to keep it the same physical amount of time. So therefore, it's important to multiply that both of these are equal to 1. We don't want to change this value. We want to keep it the same. All we want to do is change the units. So again, we need to know these conversion factors. So again, we already know how we set up the units. And we know 60 seconds is equal to 1 minute. And we know 60 minutes is equal to 1 hour. So now we know how we can set up these units so they both equal 1. For example, we know 1 minute is the exact same thing as 60 seconds. So we know these both physically represent the same thing. So we know this just equals 1. So that's good. We're not changing this value. And the same thing with hours and minutes. 1 hour is the same as 60 seconds. So again, this just equals 1. This is physically the same thing as this. So this conversion is just equal to 1. So now we're not actually changing the actual physical meaning of what this is. All we're doing is converting the units. So we know the seconds cancel, the minutes cancel, and we're left with units of hours. So our answer will be in hours. And again, we do the math. 9,000 times 1 divided by 60 times 1 divided by 60 will give you 2.5. So now we know 9,000 seconds is equal to 2.5 hours. So let's do another example. Let's say we know 1 centimeter by 1 centimeter is equal to 1 centimeter squared. However, what if we had 80,000 of these centimeters squared? How many meters squared would that be? Well, again, it's the same idea. The first thing is we set up the units so the centimeters cancel and we're left with meters. So now we have the units in what we want. But remember, this conversion has to equal 1 because, again, we don't want to change this physical amount. So this has to equal 1. So therefore, we need to find out how many meters equals how many centimeters. So this top is physically the same thing as this bottom. So therefore, this will be 1. So you look in a textbook and you see 100 centimeters equals 1 meter. So now we know our conversion factor. However, there's a problem. There's a problem because if you notice, we have centimeters squared and we have centimeters. So this won't perfectly cancel. And even if they did, we'd be left with meters when what we really want is meters squared. So these units aren't quite right. So what we have to do is we have to square this conversion. So just the way algebra works, when you square a fraction like this, that square goes to everything. Everything gets squared. The meters, the 1, the 100, and the centimeter squared, it all gets squared. So now when that all gets squared, we're left with this guy. So now when we have this guy, now the units are set up correctly. Now the centimeters squared can cancel, and we're left with meters squared. So again, the point is, if we want to take 80,000 centimeters squared and find out how many meters squared it is, you have to set up the units to cancel. So we set up our conversion factor in a very specific way that allows the centimeter squared to cancel, and we're left with meter squared. So now our answer will be meter squared. And again, the second point is, remember, this has to equal 1. We don't want to change what this physically represents. So this has to equal 1. So this has to physically be the same thing as this guy. So, and again, we explained how we do that. We look in the textbook and we see 100 centimeters equals 1 meter squared. But again, because we want things in squared, we have to square this guy. So everything gets squared. And again, we explained that. So now we know 10,000 centimeters squared equals 1 meter squared. So now we have our conversion factor squared cancels. We're left with our answer in meters squared, and we just do the math. 80,000 times 1 divided by 10,000 equals 8. So now we know 80,000 centimeters equals 8 meters squared. So let's say we have 1 meter cubed of water, which is 1 meter by 1 meter by 1 meter, which is meter cubed. So let's say we have 1 meter cubed of water, this volume of water. How many centimeter cubed water do we have? So again, in order to determine this, the first thing I like to do is set up the units. Set up the units so meters cancel, and we're left with centimeters. And again, that's what we want. So that's the first step. The second step is, remember, this has to equal 1. We don't want to physically change what this represents. So this has to equal 1. So we're not increasing what this physically means or decreasing it. It's staying the same. So we look in a textbook, we see 1 meter is physically the same thing as 100 centimeters. So again, this physically represents the same thing as this. So this fraction equals 1. So, but we see this isn't quite right. We realize this isn't quite right because we have meters cubed while this is just meters. And again, that would give us centimeters when 1 centimeters cubed. So this isn't quite right. So we need to change these units to get the units that we want. So we know how we do this. We cube this factor. And again, just the way algebra works, when we cube a fraction, everything gets cubed. So then if you do the math, you get this. So now we have the right units. Now the meters cubed will cancel, and we're left with centimeters cubed, which is what we want. And we have the math. And again, 1 million centimeters cubed physically represents the same thing as 1 meters cubed. So we know this is just equal to 1. So now we know we're not physically changing what this represents. So we've done it. The units cancel. We have centimeters cubed, which is the answer that we want. And then we just do the math. So 1 times a million divided by 1 equals a million. So now we know if we have 1 meter cubed of water, that means we have a million centimeter cubed of water. So another example, let's say this car is moving at 180 meters per minute. In 1 minute, this car travels 180 meters. How many meters is it traveling per second? If it's traveling at this particular value, this velocity, how many meters per second is it traveling? So again, the first step I like to do is convert the units, create a conversion factor in a way that gives us the units we want. So if we have minutes over second, we'll see minutes will cancel. So now we're left with meters over second, which is the answer we want, So this is how we would set up the units. And the next thing we have to do is remember, this has to physically equal 1, because we don't want to change what this physically represents. This car is traveling at 180 meters per minute. We don't want to physically change that velocity. So we want to multiply this by 1. So we're not physically changing the velocity this car is traveling at. Because if this equaled 2, we would be doubling the velocity that this is traveling at, and that's not what we want to do. All we want to do is change the units. So again, this has to equal 1. So you look in a textbook and you see 1 minute is equal to 60 seconds. So these both physically represent the same thing. So this fraction is just equal to 1. This is just equal to 1. So now we've done it. We've set up the units so minute cancels, and we're left with units of meters over second. So that gives us the units we want. And again, we're not changing this value. We're just multiplying it by 1. So now we just do the math. 180 times 1 divided by 60 equals 3. So now we know if this car is traveling at a velocity of 180 meters per minute, that means it travels at 3 meters per second. These both physically represent the same thing. All we've done was change the units. So another example, let's say water has a density of 1,000 kilograms per meter cubed. So if water has a density of 1,000 kilograms per meter cubed, what is the density of water in units grams per centimeter cubed? Well, again, we know how we do this. First, we set up the units. We set up the units in a very specific way that allows kilograms to cancel and allows meter cubed to cancel. And now we're left with unit grams over centimeters, which is centimeters cubed, which is, again, the answer that we're looking for. So first step is set up the units in a way that takes the units you have and converts it into the units you want. That's always the first step. Again, the second step is both of these need to equal 1. So again, if you look in a textbook, you see 1,000 grams is the same thing as 1 kilogram. 1,000 grams is the same thing as 1 kilogram. These both represent the same physical thing, so this equals 1. And also you can look in a textbook and see 1 meter equals 100 centimeters. But again, remember, we want things in cubed. We want things in cubed, so these can cancel. So again, even though the textbook will give us this, because we want these units in cubed, we know we have to cube everything. Again, everything gets cubed. And when we do that, we would get this value. So now we know 1 million centimeters cubed is the same thing as 1 meters cubed. So we know these both physically represent the same thing, so this fraction equals 1. So now we've done it. Again, first step is set up the units. The second step is set up the numbers, so both of these conversion factors equal 1. So now you do it. So again, kilograms cancel, meters cubed cancel. We're left with grams over centimeters cubed, which is what we want. And again, then you just do the math. And if you multiply these, divide by 1, multiply by 1, divided by a million, you would get this answer. So water has a density of 1,000 kilograms per meter cubed, which is the same thing as saying water has a density of 1 gram per centimeters cubed. Again, these both physically represent the same thing. We didn't want to change the density, the actual value of the density. All we wanted to do was change the units. So another example, let's say we have 1 day, and you want to wonder how many seconds is in 1 day. How many seconds is equal physically to the same thing as 1 day? Well, again, first step is set up the units. Set up the units. So we have one conversion factor with hours over day. So that cancels out the day. this conversion factor cancels out the hours, and this conversion factor cancels out the minutes. So again, all these units are canceled out and we're left with seconds, which is what we want. So that's the first step. Set up the units to convert the units you have to the units you want. And then the second step is, again, remember, whatever's on the top has to equal what's on the bottom. So we know 24 hours is the same thing as 1 day. We know 60 minutes is physically the same thing as 1 hour. We know 60 seconds is the same thing as 1 minute. So again, whenever you have these conversion factors, whatever's on the top has to represent the same thing as what's on the bottom. So now we've done it. We've set up the units and we've set up the actual numbers to give us our answer. So again, days cancel, hours cancel, minutes cancel, we're left with seconds. So our answer will be in seconds. And then you just do the math. And now we know 1 day is the same thing as 86,400 seconds. And also sometimes you may be taught to set these up in this dimension analysis grid, which again, these both represent the same thing. You can have this dimension analysis grid, or you can have these conversion factors. Honestly, I think this looks a little nicer, but again, it's the same idea. You set up each of your conversions, so you set up the units in a very specific way that allows all the units to cancel to give us the units you want. And again, each conversion has to equal 1. Whatever's on the top has to equal what's on the bottom. So let's say we know this car is traveling at a velocity of 25 meters per second. And let's say we know this car is traveling at this velocity of 25 meters per second for 10 seconds. So again, this car is traveling at 25 meters per second. And let's say it's traveling at that velocity for 10 seconds. How far has it traveled? How many meters has it traveled during that period of time? So I know this may seem like a very tricky question that requires a lot of critical thinking and is complex and abstract, but it's actually very easy to find this answer. What you need to do is realize you're given a velocity. You know the velocity of this car is 25 meters per second. So you have a velocity and you know the amount of time it's been traveling. You know it's been traveling for 10 seconds. So if you have a velocity and a time, how do you find a distance? How do you find out how many distance it's traveled? Well, you could see due to the algebra, it's very easy. All you have to do is take that velocity and multiply it by the amount of time. The seconds cancel and we're left with meters. We're left with meters. We're left with a distance. So it's literally just that simple. All you need to do is follow the units and let the units guide you to find your answer. Again, we have a velocity and we have an amount of time, but we want a distance. So if we have a velocity and a time, how do we get a distance? Well, all we have to do is multiply them. So now we know how to find the distance it's traveled. We just multiply these two values. So again, if we multiply these two values, we would get 250 meters. So now we know if this car is traveling at 25 meters per second and it's traveling at that velocity for 10 seconds, then we know it's traveled a total of 250 meters. And again, we see the units cancel and now we're left with meters. So it's just that simple. No complex abstract thinking, just very simple. Just let the units guide you. We know these are the units we're given. These are the units we want. So how do we get the units we want from what we're given? We just multiply them. Seconds cancel. Now we have our answer. So let's do another example. Let's say we have this flask. And let's say we know this flask has a concentration of 1,800 heme molecules per milliliter. So that's the concentration of this flask. So if we were to take 1 milliliter, we would have 1,800 heme molecules. That's the concentration. But let's say we need to do an experiment. And for our experiment, we need 45,000 heme molecules. So if we need 45,000 heme molecules to do our experiment, how many milliliters do we need? How many milliliters of this solution do we need to have 45,000 heme molecules so we can do our experiment? So again, this may seem like a very complicating, very abstract, conceptual question that's very tricky, but it's actually very easy. All you have to do is look at what you have. We know the concentration we have, and we know the amount we want. So now, based on those values we have, how do we determine how many milliliters we need? So again, this may seem like a very tricky question, but it's very simple. All you need to do is focus on the units and let the units guide you. If you have a concentration of heme per milliliters, so if you have a concentration and you have an amount, the amount of heme molecules you need, how do you take those two variables to get the volume you need? Well, again, just some simple algebra. We know if we take the amount of heme molecules and divide it by the concentration, we know the way this algebra works. You just do the reciprocal. And then once you do the reciprocal, you know now the hemes cancel, and now you're left with milliliters. So now we're left with milliliters, which is what we wanted. So again, it's just that simple. No abstract thinking, just very straightforward. You look at the units you have, and we know the units we want. We want units volume. So therefore, we know if we take this guy and divide it by this guy, that will give us the units we want. So that's all we have to do. We take this guy and divide it by this guy, and we know that will give us the units we want, so that will give us the answer we want. So we just take 45,000 heme molecules and divide it by 1,800 heme molecules per milliliter, which is the concentration, and that will give us 25 milliliters. So now we know. Now we know if we have this concentration in this flask and we need 45,000 heme molecules, we know if we take 25 milliliters, so again, if we isolate 25 milliliters, in that 25 milliliters, we would have 45,000 heme molecules. So it's really just that simple. So the point is, let the units guide you. We know the concentration and we know the amount we want. So with those two variables, how do we get volume? Well, again, we know we take this guy and divide it by this guy, and that will give us the answer. So if you're studying for the MCAT or just you're going to be a chemist or whatever, these are a lot of important units and conversions you should be aware of. For example, 1 meter cubed is the same thing as 1,000 liters. Well, 1 centimeters cubed is the same thing as 1 milliliter, which is the same thing as 1 cubic centimeters, which is the same thing as 0.01 liters. 0.001 liters. So again, these all represent the same thing. All of these volumes represent the same thing. These are all different ways to represent the density of water. These are all different ways to represent atmospheric pressure. And again, this is a lot of chemistry stuff that I'll have a link below on a video that goes into great detail on a lot of these chemistry conversion factors. And then again, these are STP standard conditions, and this is standard state conditions, and this is specific heat of water. So this, I recommend just taking a screenshot of this and just memorizing these. So one last example. Let's say we had this solution, and let's say we knew the solution had 3 moles per 1 liter. If we knew the solution had 3 moles per 1 liter, how many micromoles are there per centimeter cubed? Well, we know how we solve this. First, we need to set up the units. So we need to set up the units in a way that allows the moles to cancel, allows the liters to cancel, then allows these milliliters to cancel, and now we're left with units micromoles over centimeters cubed. So that gives us the units we want. So remember, that's the first step, set up the units. And remember what the second step is. Now we have to add in the numbers. So we know 1 mole is the same as 1 times 10 to the 6 micromoles. We'll look in a textbook, and the textbook will show us this relationship. 1 mole equals 1 times 10 to the 6 micromoles. And also we would look in a textbook and see 1 liter equals 1 times 10 to the 3 milliliters. That's a relationship we'll see in a textbook. And another relationship is 1 milliliter equals 1 centimeters cubed. So now we know all these relationships. Now we know what our conversion factors are. And remember, each of these conversion factors has to equal 1. Because again, we don't want to change this physical amount. All we want to do is change the unit. So we know each of these conversion factors have to equal 1. So again, we know this is physically the same as this. Again, the textbook told us that. So now we know the numbers. So now we have everything we need. Again, we already knew how to set up these units. So the moles cancel, liters cancel, and milliliters cancel. And now we're left with the units we want, micromoles over centimeters cubed. And we know the numbers, so again, we would just solve these numbers. 3 times 1 times 10 to the 6 divided by 1 times 1 divided by 1 times 10 to the 3 times 1 divided by 1, and that would give us numerically our answer. So now we know our answer. Our answer is 3 times 10 to the 3 micromoles per centimeter. So again, we know the solution had 3 moles per liter. So that's the same thing as saying this solution has 3 times 10 to the 3 micromoles per centimeters cubed. And again, you might wonder, why did we have to add in this milliliter? Well, again, based on the relationships that you'll usually see in a textbook, we knew how to go from liter to milliliter, and then we knew how to go from milliliter to centimeters cubed. So we had to go that extra step, because usually these are the conversion factors you'll see in a textbook. But again, it's that same idea. First step, whenever we're doing conversions, whenever we have one value and we want to convert it to new units, the first step is to set up the units. Set up the units so the units cancel and you're left with the units you want. That's always the first step. The second step is set up the numbers. Set up the numbers so each of these conversion factors are equal to 1. And that way you're not physically changing this value.